now we're going to look. Now you can keep this term or eliminate it because it does not add or add anything to the calculation. So it doesn't really matter. So remember how you try to find out what is on the left, what is on the left, or right. Simply both sides divide by exactly the same thing, all right? So 2.9 gram, 2.9 gram, excuse me, and then it's right here. So on our right, this canceled out, all gone. And then, so right here, okay, we will have 23.75 divided by 2.9, 8.1, 896557172. All right, that is your calculator's number. But what is the number you should give it to me in order to get your point? 1, 2, 3, 4, 1, 2. You can only have a 2. So make sure those 2. But now here it's 1. The one next to 1, it's 8. So you needed to move it up, and which is what we called 0.2. All right, round up, and then this, it's only half of the point. Look right here. Gram cancel out, flip your milliliter on top. All right, so this is your specific equation.
To determine the value of the unknown variable, you have to use both the graph value and the specific equation calculation value for your answer to be complete.
6b, all right? And then this one, I'm not going to give to you. You have to do it on your own because your professors also need this to grade your work. All right, so that's what we have done so far. All right, now, my question before we finish is to you. It's why do we need to have those two? What is the purpose? Why is one not enough? We need to have a 2. All right? Well, simply means if those two numbers, you can see 8.1 and 8.2 are very close, all right? Are very close to each other. And in other words, your so-called graph realistically represented data points have been given. And your specific equation relatively or realistically represent your graph. Now the question is, what if you have 6.8 milliliter? Now you have a huge discrepancy between. Did you do your graph wrong, or did you do your math wrong? The correct answer is we don't know. Then what should you do? The correct answer is start it all over again. Start it all over again, all right? My experience with a student at this level, it's usually the graph. It's usually the graph, all right, did not actually graph exactly what you are given, all right, some word here. All right, that's what we have. Some of your professors will not use this point as the origin of the graph. They want you to move one column to the right and then one row up, use this one right here. In other words, leave some of the space for your y and then leave some of the space for your x. This is a very well thought out a way, all right? Simply means give you a space to have a negative value. Say temperature, you will have a below zeros, and then so it's right here. And then say finance, and then if it's negative, it means you owe people money, so on and so forth, all right? However, in our case, there is no negative volume of, negative volume. There is no negative mass, all right? So therefore, makes no difference. Just to let you know, sometimes you should think, should I leave some space to example? Because that will give you some really, really good self-checking space. For example, if you somehow graph this wrong, and then your line, this is the volume, this is the mass, like so, then you know you have made a boo-boo, because there is not any negative volume, there is not anything called a negative mass. So you know you made a mistake. So you need to redo it again, all right?
Y-intercept is a point which the straight line or the slope crosses on the y-axis. For our course, which uses the linear expressions, we do not have any x-intercept. Your graph plotting discussion is now complete. Here is a graph plotting checklist for your review. Make sure you complete pages 17 to 22 in your lab manual based on your professor's instructions.